Standard EE3, we're going to estimate and also compare very small and very large numbers. This skill is in preparation for scientific notation, but we're not quite using scientific notation here. Number 1, which is the best estimate of this number, 7,625,700,263? So I'm thinking, what would this round to, first of all? Well, this first digit is a 7, and that 6 to the right of it would make it round up. So we would end up with about 8 billion. And I could write that as a power of 10. That is the number 8 times 1 billion, which we could rewrite 1 billion as 10 to the 9th power. We can notice, by the way, it's 1 followed by 9 zeros, which is 10 to the 9th power. And so this is answer choice D. Number 3, which number is the best estimate of 0.00003762? Well, I look at the first digit, that's not a 0, and that's this 3. The 7 would make it round up to a 4. So we're dealing with the number 0.00004 that we're going to get an estimate that we've estimated. Now we're going to write it in this form to represent that this is a very small number. And I could write it as 4 times 0.00001, and that is a power of 10. It's actually going to have a negative exponent, and I could just count my number of decimal places that this moves. 1, 2, 3, 4, 5 places. So this is to the negative 5th power. And that is answer choice B. I do want to think about this just a minute. If we're dealing with these negative powers of 10, that means they're values that are less than 1. So if we think of 0.1, we know that's just 1/10. It's 1 over 10 as a fraction. And then I could think about this number that we were just given. Well, this number, 0.00001, is the same as 1 out of 100,000. Notice that that digit 1 is in the 100,000th place. So this 1/10 is like saying 10 to the negative 1st power. Thinking back to our exponent rules, 10 was in the denominator. It had an invisible 1 for an exponent, so when we move across the fraction line, it's 10 to the negative 1st power. This one is like 1 over 10 to the 5th power, which is 10 to the negative 5th power. So that's just a little bit of background using exponent rules to help understand these values, these powers of 10. Number 6, the mass of a sesame seed is 0.0046 grams. The mass of a pollen grain is 0.00000000513 grams. About how many times greater? That's important. How many times greater is the mass of a sesame seed than the mass of a pollen grain? So when I see a phrase like how many times greater, it is going to be comparing. And that word means it's comparing in multiples. So if we compare without it being times, then we're just dealing with subtraction. But when we're comparing multiples, it says how many times greater, how many times more, how many times larger, then this is division. So I'm going to divide the mass of the sesame seed by the mass of the pollen grain. So I'm just going to write those values out for now. 0.0046 divided by, and we know this is quite a large number, 0.0001. we have 9 zeros after the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, then 5, 1, 3. And we can just go to our calculator and divide this out. Well, this is the number I get in my calculator, and it probably keeps on going because it went all the way across my screen. However, it gives us this nice little word, about, so we could get an estimate of this. So this is pretty close to 9 followed by 6 zeros, which is 9 million. And we could write that as 9 times 10 to the 6th power. So it's about that many times greater of mass for the sesame seed than the pollen grain. Number 8 says this number, negative 0.0084, can be estimated by negative 8 times the power of 10. What is the power of 10? So we have this number, negative 0.0084, and we could estimate it. So it's just saying when we estimate, we're going to round to this largest place value, in this case the 8. The 4 will make it stay the same, so this stays 8. And we could write it as negative 8 times 0.001. So let's just think of what that power of 10 would be. Well, that's times 10, and I could quickly just count to figure it out and say, well, my decimal place moves 1, 2, 3 places. And since this is a small number, it's less than 0, I'm going to use the negative exponent. And we have found this number, but the question is asking, what is the power of 10? Well, the power of 10 right here was negative 3. Standard EE.4 is about scientific notation. Problem number 1, how is this number written in scientific notation? Well, the first thing I'm going to do is find the first digit that's not a 0. That would be this 4. I write down that number, and then I'll place a decimal and write all the digits that fall behind it until we had all zeros. So we had all zeros before this point. My first digit that was not a 0 was a 4, and that's where my decimal was placed, was after that first digit that wasn't a 0. And now I just want to know what the power of 10 is. So I'm just going to count. I'm going to say my decimal moves 1, 2, 3, 4, 5, 6, 7 places. This was a small number, so it's a negative 7 because it's a number that's less than 1. This matches answer choice C. Number 8 says to write each number in standard form. So they're given in scientific notation. I want to write them in standard form. So I'm just going to look at my decimal value for this first one, 3.501. We want to move 4 decimal places, and this will be a large number. So to make this number a large number, I'm going to go to the right. 1, 2, 3, 4 places. I need a 0 placeholder, and then just write the number, 35,010. Our next answer choice, 8.190. We're going to move our decimal negative 2 places, meaning this will become a small number. So I'm going to move to the left 1, 2 places. We'll use a 0 placeholder, and we get this decimal 0.0819. I don't need the 0 at the end. And I can use a 0 placeholder in front of the decimal. It's not necessary though. Our next value, negative 1.37, I'm going to ignore the negative just a moment and write the 1.37. We have an exponent of 5. It's positive, so it's going to become a larger number, ignoring the negative sign for a moment. So we're going to go 1, 2, 3, 4, 5 places to the right. And I'm going to write that negative in my answer to write negative 137,000. Our last answer, our last number we're going to write, I'm going to ignore the negative for a moment and say, okay, it's times the power of 10, that's negative 4, so this is going to be a very small number. So move my decimal to the left 4 places. 1, 2, 3, 4. And I'll have to use some 0 placeholders. And then I'm going to go back in and write the negative at the end. So here's our number, negative 0.0006041. And I can write a 0 in front of that decimal at the beginning as a placeholder. Number 15 is a word problem. The mass of a water molecule is 3 times 10 to the negative 23rd grams. What's the mass of 50,000 molecules? So it gives us one molecule, 3 times 10 to the negative 23rd grams. And it asks, what's the mass of 50,000 of those? So I'm just going to multiply that number times 50,000. I can type that right into my calculator, and I get answer choice B.